Welcome and hello. This is a video exercise using the FHWA hydraulic toolbox titled Riprap Sizing at Different Channel Locations. So what we're going to do is have a trapezoidal shaped channel as you see on the screen, and we're going to identify which class of riprap we need for the two different slopes, 1% and 2%, at the 5 different locations that are available in the riprap calculator. So this is the problem statement. We're asked to find the specific riprap class for the different slopes and locations. You can see we have the channel geometry right here, 3 feet of depth, 2 different slopes, and the Manning's roughness coefficient, as well as some riprap data. So let's go ahead and get started. We're going to be using the channel calculator as well as the riprap calculator in the hydraulic toolbox. I'm going to start by going up to calculators and click on new channel analysis. In the description of this video, I will leave a link to the lesson that covers both the channel calculator and the riprap calculator. All right, channel analysis. I'm going to start by renaming this one and just call it channel 1.5%. So let's open up that and define the data. Right click, channel data. Now this is going to be a trapezoidal channel. Here is the data once again. So the side slope is 2:1. The base width is 10 feet. The depth is 3 feet. And then we have the roughness and 2 different slopes. Oops, this is supposed to be 1.5%. All right, so let's go ahead and enter that data in here. So side slope is 2:1. The channel width is, okay, so this is in metric units. Let me click OK, switch the units to US customary. That's what I want. And then right click channel data. And here we go, 2. All right, so now the base width is 10 feet. The longitudinal slope is going to be 1.5%, so that's 0.015, and then Manning's roughness coefficient is 0.035. We don't know the flow rate. That's something we're going to calculate, but we do know the depth is 3 feet. So select 3 and then click on calculate. Boom, here are the parameters. So some of the critical parameters are things like maximum shear stress, top width, we'll see that, average velocity. So some of these parameters will be copied over into the riprap calculator once we specify this specific channel. Right, the flow rate happens to be 402 CFS, and then here's the plot if you're interested. It's a 2:1 side slope, but just like the problem statement, the scales are a little bit different, so it looks a little bit out of scale. All right, so that is all we need to do for our channel with 1.5% longitudinal slope. I'm going to just go ahead and make a copy of that calculator. So duplicate and then rename, change the percentage to 2.0, and then just go ahead and edit this. So the only change I need to make is changing this longitudinal slope to 2%. Okay. I'm going to recalculate the flow rate. So click on calculate. 402 is now 465 CFS, and then a number of the other parameters over here changed as well. Okay, so I think we're done here with the channel calculator. I'll click OK. This was really just a preliminary step that's required for the riprap calculator, which is what we're ready to do right now. So project, right click, riprap analysis. So what I'm going to do is rename this and call this riprap dash 1.5%. So I have a separate calculator for each of my two different channel slopes, and then double click to open that up. At the very top, we first need to specify the structure type. So this first one here, revetment channel slope for 2% or less is the one we want. But if you happen to have a channel slope greater than 2%, you'd select this one right here, greater than 2%. There's a number of other options such as piers, abutments, culverts, waves. So yeah, we're going to go with the first option. And then we need to select the channel. So we could select channel 1.5%. And if we didn't already perform that previous step of creating the channel, we would go ahead and just create it right here. But I like to kind of have my calculators separated and organized like that. So channel 1.5% has already been created. Here is some of the results from that channel calculator. This should look familiar. Design flow 402 CFS. The channel depth is 3 feet. The side slope is 2:1, and the top width of 22 feet. That all looks good. So we'll transfer the values down here. So if I scroll down here, we now have a number of input parameters that are associated with the riprap calculator. some of which are taken from the channel calculator results, but a few of them I need to specify myself. So let's go back to our problem statement. Rounded rock, safety factor, and all locations is the information we're given. Now, if there's other data to provide and it isn't in the problem statement, I'm probably just going to go with the default value that's set in the Riprap calculator. All right, so back to the input data. Natural channel, the depth of flow is 3 feet. That's all correct. Okay, so for the riprap shape right here, not angular, but we want to use rounded rock. And what that did is it changed this stability coefficient to 0.375. Blanket thickness coefficient, it's not given. The channel cross-sectional average velocity, 8.39 feet per second. That was, again, a result from the channel calculator. Center line radius, so that's something we're not going to use with the straight channel. By the way, the protection location, this is the 5 different locations that we're going to be also testing for. So our options here is straight channel, inside of bend, outside of bend, downstream from the concrete channel, and end of lake. So let's just start with straight channel, and then we're going to go ahead and change this and then look at the results for the 5 different protection locations. All the other data is pretty much as it is. We're just going to use what we have. Like the bank angle is 2 to 1. That represents a 26.2 degree angle. And then the specific gravity of the riprap and water. Oh, I'm sorry, factor of safety. We need to change this also to 1.2. And then I'll tab off. Okay. So let's scroll down. And what we have below are our results. What governs the riprap size, which is class 2 for this specific input data, is, among other things, the D50 size. So the D50 size right here is 211 millimeters. So I think that's about 8 inches, maybe a little bit more. I don't have my calculator with me, but we'll go with that. So basically, the riprap class 2 is the smallest riprap class that has a D50 size greater than what was the minimum required D50 size based on our input data. So if we look down here for class 2, D50 is actually 241 millimeters. So if our riprap calculations required a D50 size greater than 241 millimeters, then we'd have to upgrade to the next riprap size, which is class 3. So that's how that works. I'm going to go back to the PowerPoint here. This is also where I'm going to be keeping my results. So this is the results page before we fill it out. The one that we've already created is for the straight channel with a slope of 1.5%. So the riprap class right here is going to be 2, class 2. This is just using Roman numerals, so I'll do that as well. Next, what we're going to do is change the location for these 5 different locations and then update the riprap size for the 1.5% slope and the 2% slope. Go ahead and say 2.0. Okay, there we go. Going back to that riprap size calculator right here, the D15, 50, 85, and 100%. If you're curious what the D50 size and these other sizes are for the different classes of riprap, I'm going to click OK and introduce you to the rock sediment gradation calculator. So I'm going to go up to calculator, and then we have rock sediment gradation analysis. This isn't a calculator we're really going to use for analysis, but it's just a good location to identify the different riprap classes. So this third button here, add standard riprap gradation. Click on that, and then it's called the riprap 1, class 1. These are just default values, but you could just call it class, or how about riprap class 1. Okay. And then click OK. Or actually, you don't even have to click OK. You just click on the riprap class. And then down here are the sizes. So for D15 and D15 upper and lower, D50 upper and lower range, D85 upper and lower range, and then D100 upper and lower range. You can also plot the gradation. So you see we have an upper and lower range for these 4 different percent finer of 15%, 50%, 85%, and 100%. Of course, this is class 1. What we were dealing with for our first calculation was class 2. So I'm going to, again, add another riprap gradation. Going to change this to class 2 now. It looks like it goes up to class 7. Oh, I'm sorry. Hold on. Class 10. That's right. And then user defined. But here's class 2. And when I selected that, now we have a larger range for D50 that goes from 203 up to 279. Oops, I changed the wrong one. So let me change this back to class 1. Click on Riprap class 2. I'm going to rename this to Riprap class 2 and then change the drop down to class 2. There we go. And if I plotted it, you can see that this is class 1 right here with the outline of blue, and then the outline of magenta is Riprap class 2. It's just a little bit larger. Okay, so let's close that up. Riprap class 2 here says it's between 203 and 279 millimeters for the D50 value. So if we go back to our Riprap calculator and then scroll down for D50, it's saying 241. So that's probably like an average. Yeah, this value is an average of the size fraction range for the selected riprap class. Okay, so just so you know where these numbers are coming from, now you have an idea. So what we've done so far is only test the protection location of a straight channel. Next, I'm going to check the other 4 locations, and this is for the 1.5% longitudinal slope channel. So let's go with inside of bend, right? D50 is 211, which means D50 of 214 from class 2 is satisfactory. How about outside of bend? Scroll down, we have, again, 211, so class 2 works. And then for downstream from concrete channel, scroll down. Class 3 is what I'm seeing because the calculated required D50 is 264. So we had the increase to class 3 D50, which is an average of 317. And then finally, the last location is end of dike. And then scroll down. And then again, class 3, 264. That's to round up to 317. All right, so back to our results here. We had class 2, class 2, class 3, and class 3. All right, so we're halfway done with the results, but well more than halfway done with the total exercise because finishing up the numbers for this riprap class for the slope 2% channel should be a lot quicker. All right, so let's go ahead and knock out these results. We're going to go back to our calculator, click on OK, and then I'm going to just right click, duplicate the riprap calculator for 1.5%, rename it, and then type in 2.0%. Click on that, open that up, and then the only change we need to make here is the channel is going to be 2.0%. So the numbers have updated with the new calculations with the higher flow rates of 465 CFS. And of course, there's higher shear stress and higher velocities. I'm going to click on this transfer values from the channel calculator just to be safe. And then I also need to make sure that I'm using the rounded rock. There we go. That's good. Safety factor is 1.2. And now let's go ahead and just cycle through the 5 different locations here. So straight channel is saying class 3 now. D50 is 302, so it rounds up to 317. The next location is going to be inside of bend, also class 3. Now for inside of bend, it will depend on the curvature of the centerline radius curvature right here, which I didn't specify, so I'm just going to leave at a large number. But just for kicks, let's go ahead and change this. So how about 100 feet of the radius could possibly require higher riprap class. So class 3 right now, D50 is 302. If I tab off and then scroll down, wow, yeah, D50 is now 700, requiring class 8 riprap. So maybe that'll be the subject of another lesson. Since I didn't specify that, I'm just going to change this back to an absurdly large number, effectively no radius. All right, so we have a couple more to go. We have outside of bend, that is class 3, and then 2 more downstream from a concrete channel. That's going to be class 4. The D50 is 378 millimeters, just below 399. And then the final location is the end of a dike. Again, 378 millimeters, which fits into class 4. All right, so our final results, let's go ahead and update this table. We had class 3, 3, 3, and then 4, and then 4. All right. So that's it for this exercise. These are our results. We identified the appropriate riprap classes for these different locations in our river channel for 2 different slopes of 1.5% and 2.0% using the riprap calculator in the FHWA hydraulic toolbox.